Hey everybody, this is it. This is where it's all been going. This is our target for this quiz cycle where we're multiplying polynomials. We want to get to the point where I can multiply any polynomial, doesn't even matter, by any other polynomial, any size. And so that's our goal. By the end of this, I want you to be able to multiply two polynomials, binomial or larger. We don't even care how many terms there are. And we want to do this using the distributive property. Remember, we learned how to multiply a monomial times a monomial, and then we learned that when you multiply a monomial times a polynomial, it's really just the distributive property. So when I multiply a polynomial by another polynomial, I'm just doing the distributive property over and over and over and over again. And what you'll find is that I have two ways I'm going to show you how to do this. And I'm going to work it both ways. So every example that I have, and I have 5, really this time, not making that up, I have 5 examples and we'll work them both ways. Actually, I think there are 6 now that I've said that. Man, counting's hard when you're a math teacher. But anyway, I will show you how to do it using the distributive property, and I'll show you how to do it using something called the box method. Both will get you the exact same answers. It's just 2 different ways of looking at the problem. You can pick whichever one you like best and stick with it. You don't have to always do both, but I want you to have options as far as how to do this. So here we go. When we're multiplying polynomials of any size, doesn't matter how big they are, distribute each term of the first polynomial through the entire second polynomial. Then combine like terms, and then make sure your answer is in standard form. Always, always standard form. It's just good practice. Now, here we go, example 1. This is the one that I warned you about in the very first part when we talked about the objectives. So we're going to learn how to do this first as multiple instances of the distributive property. And this is really what's going on. So if you understand this method, that gives me great hope that you really understand the math behind this. So what I'm going to do is I take the first term of the first polynomial times the whole second polynomial. And then I take the second term of the first polynomial times again the whole polynomial. And what you'll see is that that second polynomial repeats itself twice. That 6m plus 5 is there and there. And in front of it being distributed is each individual term of that 3m plus 4. And now all I have to do is multiply all this out, combine like terms, and rewrite it in standard form. So 3m times 6m is going to be 18m squared. 3m times positive 5 will be 15m. Now I take positive 4 times 6m, that would be positive 24m, and then positive 4 times positive 5, which is positive 20. Now, once I've done all this distributing, I look at what I have and I want to see if there are any like terms I can combine. And if you look, 15m and 24m, I can now combine those. So I would say this is 18m squared, that part doesn't change. 15 plus 24 would be 39m plus 20. I need to now write that in standard form. Good news for me, it already is. So if you can do that right there, that is everything we've got. All this is the distributive property multiple times. Now there's another way to distribute this using what's called the box method. And this is pretty nice and pretty handy. So here's what you're going to do. My first polynomial has 2 terms. So I'm going to draw a box and divide it into 2. And here I'm going to write 3m. And here I'm going to write 4 because it was positive 4, right? And then my second polynomial has 2 terms. So I'm going to make 2 columns. And I write 6m. And then it was positive 5. Now all I have to do is for each box multiply the things that are on the outside. So 3m times 6m is 18m squared. 5 times 3m is 15m. 6m times 4 is 24m, and 5 times 4 is 20. And now what I do is I take everything in each box, 8m squared plus 15m plus 24m plus 20, combine like terms just like I did before, and I end up with the exact same answer, 18n squared plus 39m plus 20. So there you go. I can do it as the distributive property, or I can do it as the box. But notice that they both end up giving you the exact same answer because they're really doing the same thing. Here I'm taking the 3m and multiplying it by 6m times 5. Here I'm taking the 4 and multiplying it by 6m plus 5. So let's take a look now at a couple more of those. Example 2. For the distributive property version, I've got 6n minus 1 times 4n minus 4. So now I'm going to rewrite this. First term times the whole second polynomial. Second term, which is negative this time, so I write negative 1 times the whole second polynomial. And now we just multiply till our hands fall off. 24n squared. A lot of people forget that. You have to add the 1 plus 1 is 2. 6n times negative 4 would be negative 24n. Negative 1 times 4n would be minus 4n. And then negative 1 times negative 4, negative times a negative, is a positive. I can combine these two middle terms, and I end up with 24n squared minus 28n plus 4. It's already in standard form. Yay team, that's my answer. So now let's look at the same thing using the box method. And again, this is going to give us the exact same answer. I have 6n and negative 1. Over here I have 4n and minus 4. 4n times 6n is 24n squared. 6n times negative 4 would be negative 24n. 4n times negative 1 is negative 4n, and negative 4 times negative 1 is positive 4. Didn't really have to write positive, but hey, nobody got hurt. Rewrite each individual one, 24n squared minus 24n minus 4n plus 4. And you can see now it's the exact same situation as before. Combine like terms, and I get the same answer right there. Example 3. Now we're going to see kind of a different situation. If you'll notice the title up here, we're going to multiply this in the same way, but we're going to end up with something called the difference of two squares. And so our answer will look perhaps different than we're used to. So if I take 2p plus 3, 2p minus 3, we're going to multiply those just like we've done before. First term times the whole second polynomial. Next term times the whole second polynomial. And watch what happens here. This is kind of neat. 2p times 2p is 4p squared. 2p times negative 3 would be minus 6p. Positive 3 times 2p would be plus 6p. And then 3 times negative 3 would be minus 9. Our middle terms will combine as they so often do, but negative 6p plus 6p is 0. It goes away, leaving us with just a binomial 4p squared minus 9. And so you can now see that this thing ends up being a difference, subtraction, of two squares. 4p squared is just 2p times 2p. Negative 9 is, or 9, excuse me, is a perfect square, 3 times 3. So that's where the name comes from. But just be aware that if we have this situation where it's something plus a number and then the same thing minus that same number, we can have a situation where the middle cancels out. We can see this in the box method as well, and I will jet through this pretty quickly because I think, or I hope anyway, you're getting the idea. 2p and 3 over here. 2p and negative 3. Don't forget the signs. That's where you mess this up. 2p times 2p will be 4p squared. That's another one not to forget right there. Minus 6p plus 6p minus 9, and now I can just rewrite my whole thing. You'll see just as before, the middle two terms are going to cancel each other out, leaving me with 4p squared minus 9. And just as a reminder, you don't have to do this twice every single time. Pick one of these methods that you like, either the distributive property or the box method, and stick with that one. You don't have to do them both. I'm doing them both so that whoever prefers one or the other can see it. All right, example 4. Whoa, what's going on here? A binomial squared. So for our distributive property one, we're wanting to do 5k minus 7 squared. Well, that just means 5k minus 7 times 5k minus 7. And so when I do this, it's the same as before. 5k times 5k minus 7, and then negative 7 times 5k minus 7. So everything's kind of repeating itself, but the process is exactly the same. So I would say minus 35k. I'm just multiplying through. Again, don't be afraid to go for your calculator if the math is a little daunting as far as the numbers go. That's fine. Be careful here. Unlike a difference of two squares where these cancel out, when I square something, they're not going to cancel out. Negative 35 minus 35 is not 0, but rather in this case minus 70k. And so that's what we're looking at there. In the box method, I can put these up there, except it's going to be the same on all sides. It's 5k and a negative 7, no matter where we look on this. And when I multiply, again, 5 times 5 is 25, k times k squared. Don't forget that square, folks. Minus 35k, minus 35k, and plus, now 49, because a negative times a negative, and we end up with exactly the same thing. And my dearest hope is that you're getting so bored with this because you already know how to do it. That would be amazing. And so there you go. Example 5. Now things are a little more serious. Got your deep breath? You got this? All right. So let's do this as the distributive property, and I'm going to leave all the space for it because we got a lot of distributing to do here. It's a binomial times a trinomial. That's okay, we know how to do this. All we have to do is take the first term, the first polynomial, times the entire second polynomial. We don't care how big it is. It can be as big as we want. And then we take the second term of the first polynomial, multiply it by the whole second polynomial. We don't care how big it is. As the great philosophers of old might have said, we ain't scared. We can do this. So now that we have written this as distributive property, that times that times that, let's distribute this. N times 3n squared will be 3n cubed. N times negative n will be negative n squared, and n times negative 7 would be minus 7n. Now I come over here and we're doing the same stuff. Negative 2 times 3n squared, negative 6n squared. Negative 2 times negative n is going to be positive 2n. Negative times a negative is positive. And then negative 2 times negative 7 would be plus 14. Now I'm not done. I have to combine like terms, and I have to put this in standard form. So let's combine like terms. My first term is going to be a cubic term. There isn't one of those, so I just copy it down. There's nothing to combine it with. Next I see a squared term, and I see another one right there, and that's all for those. So I combine them. Negative 1n squared minus 6n squared would be minus 7n squared. Notice the variable stays the same. We're adding here. We're not multiplying. And then I have a linear term and another linear term there. Negative 7 plus 2 would be negative 5n. And then finally, a constant term that has nothing else to combine with. And this is in standard form, So, boom, there you go. I've multiplied. It's long, but it's doable. Take your time, write down everything. Don't try and do this in your head. That is a recipe for disaster. There's simply too much going on. It's not that you can't do the math in your head, it's just that you can't keep track of that much stuff going on. That's not a problem with your intelligence, that's just a problem with human brains. This is why we developed paper, is so that we could keep track of this stuff. Write it down. You're doing yourself a big favor. So let's look at this thing now using the box method. I can do the same thing with a box and get the same result. So if you like the box better, here's how it goes. If you don't like the box better, feel free to skip this. So n minus 2, and then my other polynomial is 3n squared, negative n, and negative 7. And so I'm going to divide those off. So now I have my 3-term polynomial across the top, my 2-term across there, and I just start multiplying. N times 3n squared, 3n cubed. N times negative n is negative n squared. N times negative 7 is going to be negative 7n. Negative 2 times 3n squared is negative 6n squared. 2n. And 14. My goodness, that's a lot of stuff going on there. And now what I can do is just write down all of those. Minus n squared, minus 7n, minus 6n squared, plus 2n, plus 14. And now I'm in the same place I was before. I just have to combine like terms, like say those right there, giving me 3n squared minus 7, or 3n cubed, excuse me, minus 7n squared. I've got n's there and there. Negative 7 plus 2 is negative 5n, and a 14 all out there by its onesies. It is in standard form, which means that, friends, is my answer. So this is long, but it is not necessarily complicated. You can, in fact, do this. All right, one final example. Whew. Seriously, take a breath on this one. We've got 3 polynomial, or 3-term polynomials here, multiplying a 3-term times a 3-term. We can do this either way. Let's start with the distributive property way. So first one times the whole second polynomial. Then my second term of the first one times the whole second polynomial. I have to write tiny here. And then finally my last term times the whole thing. Now I distribute for everybody's sake. I'm going to do this quickly. So 2p to the 4th plus 8p cubed minus 12p squared. That's my first one. Now I'm moving over here to this one. I have plus 3p cubed plus 12p squared minus 18p. And then over here, plus p squared plus 4p minus 6. Write this down. There is no doing this in your head. Write it down. So now I have to combine like terms. I start off with a 4th degree term, and there is no other one like it. Then I'm going to look next for any 3rd degree terms. There's one, and I don't have any others. 8 plus 3 would be 11p to the 3rd. Next up, I have squared terms there, and look at this. I have 3 of them. So make sure you look all the way through. Negative 12 plus 12, that cancels out and gives me 0, plus 1 more, so that would be plus p squared. Next up, I have a linear term, negative 18p plus 4p would be minus 14p, and then my lonely minus 6 out there with no help. It is mercifully in standard form, so we don't have anything to do past that. And there you go, friends. It's ugly, but it's not difficult. It just requires patience, discipline, and writing everything down. So let's look at it in box method. If you like that better, we can use the box. Ain't nothing wrong with that. So I'm going to draw my admittedly larger box for this one. And then I want my first polynomial down the side, p squared, 3p, and 1. And then my second polynomial across the top, p squared, 4p, and minus 6. Don't forget your sign. Draw lines between each of the terms. Now we're going to distribute till our brains fall out. So here I've got 2p to the fourth, 8p to the third, minus 12p squared, 3p to the third, 12p squared, minus 18p, p squared, 4p, minus 6. Whew. Now, I have to write all of that down. 8p cubed minus 12p squared plus 3p cubed plus 12p squared minus 18. Notice I'm using the signs from there to help me know whether I'm writing a plus or a minus. 4p minus 6. Now, combining like terms, there's nothing that's like that fourth degree term, so it's that. For my cubic terms, my third degree, I have there and there, so that's going to be plus 11p cubed. I have 3, count them, 3, that can happen, of my squared terms. There's one right there, that should be a squared, I don't think I wrote that in there. Negative 12 plus 12 is 0, plus 1, so I have plus p squared. Now I have 2 linear terms. Negative 18 plus 4 is minus 14p, and my minus 6. And thank goodness it's in standard form because I don't know how I'd do that otherwise. And there you have it. Ladies and gentlemen, if you can do that, you have mastered polynomial multiplication and you are ready for the next challenge. Good luck, my friends.